You went to sleep last night. You closed your eyes, your breathing slowed, and from your own perspective, nothing happened. 8 hours passed in what felt like a blink. You woke up and assumed your body had simply been waiting for you to return. It wasn't waiting. It was working harder than it works at almost any point during your waking hours, and almost none of what it was doing has ever been explained to you. That gap, between what your body actually does in the dark and what you were ever told about it, is one of the most significant pieces of missing information most people carry through their entire lives. Tonight, when you lie down again, a process will begin that is so precise, so layered, and so strange that the researchers who study it still argue about what it means. What they don't argue about is this: if you interrupt it, the consequences reach into almost every system that keeps you alive. If this is already making you reconsider something you do every single night of your life, subscribe and hit like. There's a lot more where this came from. Now, let's go deeper. For most of the 20th century, sleep was treated by science as a passive state. The brain quieted, the body rested, activity dropped. This was the working assumption behind nearly every textbook written before the 1950s, and it persisted long after the evidence began to contradict it. The assumption was intuitive. You close your eyes, you stop moving, your heart slows. What could possibly be happening? Everything. It turns out almost everything. The modern understanding of sleep began to shift in 1953, when Eugene Azarinsky, a graduate student at the University of Chicago, noticed something strange while monitoring his sleeping son with an electroencephalograph. The boy's eyes were moving rapidly beneath his closed eyelids. His brainwaves, rather than flattening into the slow rhythms expected in sleep, were spiking in patterns that resembled those of a wide-awake, alert person. Azarinsky brought this finding to his supervisor, Nathaniel Kleitman, who was already considered the father of modern sleep research. Together, they published the discovery of what would become known as rapid eye movement sleep, REM, and the field of sleep science was permanently changed. What they had found was not just a curiosity. They had found evidence that the sleeping brain was not resting at all. It was cycling through states of intense, structured activity that repeated across the night in a pattern so consistent it could be measured, predicted, and mapped. In a typical night, your body passes through 4 to 6 sleep cycles, each lasting roughly 90 minutes. Within each cycle, your brain and body move through distinct stages. The first stage is a shallow drift. Muscles relax, heart rate drops, body temperature begins to fall. The second stage introduces what neurologists call sleep spindles, which are bursts of oscillating neural activity that appear on an EEG as brief, rhythmic surges. These spindles are not random noise. Research published in the journal Sleep has shown they are directly tied to the consolidation of procedural memory, the kind of memory that stores how to perform physical skills. Every spindle is a moment of learning, occurring while you are completely unconscious. The third stage is slow-wave sleep, the deepest phase, and this is where things become genuinely strange. Your brain, during slow-wave sleep, is generating enormous, synchronized waves of electrical activity, delta waves, that pulse through the cortex at a frequency of less than 4 Hz. This is the stage most resistant to waking. It is also the stage during which the pituitary gland releases the majority of the human growth hormone your body will produce that day. Not trickles, not traces, the bulk of it. A study published in the Journal of Clinical Endocrinology and Metabolism found that in healthy adults, more than 70% of total daily growth hormone secretion occurs during the first slow-wave sleep episode of the night. This hormone is not just for children growing taller. In adults, it governs tissue repair, muscle synthesis, fat metabolism, and immune regulation. Your body is running a repair cycle. It requires you to be unconscious to do it. But the most significant discovery of the last 2 decades, the one that changed how researchers think about sleep entirely, is something called the glymphatic system. In 2013, a team led by neuroscientist Maiken Nedergaard at the University of Rochester published findings in the journal Science that described a previously unknown waste clearance mechanism operating in the brain. The glymphatic system works like a biological pressure washer. During sleep, and specifically during slow-wave sleep, the cells of the brain actually shrink by as much as 60% in volume. This shrinkage opens channels between the cells, and cerebrospinal fluid floods through those channels at a dramatically increased rate, flushing out metabolic waste products that accumulate during waking hours. One of the primary waste products it clears is beta amyloid, the protein that, when it accumulates in excess, forms the plaques that are a hallmark of Alzheimer's disease. Your brain generates beta amyloid continuously as a byproduct of normal neural activity. While you are awake, it builds up. While you sleep, it gets flushed away. This is not a metaphor. This is a mechanical process. The cerebrospinal fluid physically moves through your brain tissue and carries the debris out. Nedergaard's subsequent research, published in Science in 2019, found that this clearance is far more efficient in certain sleep positions, and that the system functions at dramatically reduced capacity if sleep is cut short or fragmented. The implication is not subtle. Every night you sleep poorly, you leave more waste behind. Over years and decades, that accumulation has consequences that researchers are still working to fully quantify. But the direction of the evidence is consistent, and it does not point anywhere reassuring. While the glymphatic system is running its pressure wash, your immune system is doing something equally precise. Levels of certain cytokines, proteins that coordinate immune response, rise sharply during sleep. Interleukin-1, interleukin-6, and tumor necrosis factor all increase. A study from the Max Planck Institute of Psychiatry found that T cells, the immune cells responsible for targeting specific threats the body has encountered before, form a stronger bond with the tissues they need to reach during sleep. This bond, mediated by molecules called integrins, is disrupted by the stress hormones that circulate when you are awake. The practical consequence is that your immune system literally works better at night, not because your body is resting, but because sleep actively creates a chemical environment in which immune cells can function at their peak. This is why fever often spikes at night. This is why wounds heal faster in people who sleep adequately. This is not your body shutting down. This is your body choosing to run its most critical maintenance operations during the window in which interference from waking life is minimized. And then REM sleep begins. If slow-wave sleep is the repair workshop, REM is the archive room. During REM, the hippocampus, the brain structure most directly involved in forming new memories, begins replaying the events of the previous day. Not randomly. Research from the Massachusetts Institute of Technology, led by neuroscientist Matthew Wilson, showed that the hippocampus during REM sleep fires in sequences that directly mirror the patterns it produced during waking experience. The brain is not dreaming randomly. It is deliberately revisiting, evaluating, and filing the information it collected while you were conscious. Some of it is strengthened, some of it is discarded. The process determines, without your input or awareness, what you will remember tomorrow and what will be gone. During REM, there is one more thing happening that almost nobody explains when they talk about sleep. The brainstem sends a signal that actively paralyzes the major muscle groups of your body. The mechanism is called REM atonia. It is a deliberate suppression of motor output, designed to prevent you from physically acting out whatever your brain is processing. It is not a side effect, it is a feature. And when it fails, which it does in a condition called REM sleep behavior disorder, people punch walls, scream, and run into furniture while still fully asleep. The paralysis is not something that happens to you. It is something your nervous system does with extraordinary precision every single night to keep you still while the most intensive processing of your day occurs. Drop a comment below. Did you already have any sense that this much was happening? Or did this completely change how you picture the hours you spend unconscious? What makes this harder to sit with is not just the complexity of the process. It is what happens when the process is cut short. Sleep researcher Matthew Walker, whose work at the University of California, Berkeley has traced the downstream effects of sleep loss across multiple systems, has documented that a single night of 4 to 5 hours of sleep reduces the activity of natural killer cells, a key component of cancer surveillance, by 70%. A single night. The immune suppression is not gradual, it is immediate and severe. The Centers for Disease Control has classified insufficient sleep as a public health epidemic, not a lifestyle inconvenience, an epidemic. The World Health Organization has similarly recognized that night shift work, which structurally disrupts the sleep architecture described here, is a probable carcinogen. The disruption itself, the interruption of the cycles, appears to carry biological risk independent of any other behavior. You were taught to think of sleep as the absence of your day, the pause between the parts of your life that matter. You were not taught that the hours you spend unconscious are the hours your body uses to clear neurotoxic waste from your brain, rebuild immune defenses, consolidate what you learned, and run a hormonal repair cycle that no other window in the 24-hour period can replicate. You were not taught this because for most of modern history, medicine didn't know it either. The glymphatic system was discovered 11 years ago. The precise role of sleep spindles in memory consolidation is still being mapped. The full scope of what REM atonia protects against is still being studied. This is not settled, complete knowledge being withheld. It is a field in the middle of realizing that sleep is not a gap in human life, but the infrastructure beneath it. Every system you rely on to function was built with the assumption that you would spend a third of your life unconscious, letting it run. If this changed how you see something you do every single night, subscribe so you don't miss what's next. Like the video if this is the kind of thing you want more of. The question that remains, and it is one that sleep researchers have begun asking in peer-reviewed literature, is what it means that modern life is structured almost entirely around minimizing the time spent in that state. Schools start before slow-wave sleep cycles are complete in adolescence. Offices are lit to suppress the melatonin that initiates sleep onset. Devices emit light at wavelengths specifically calibrated to keep the brain alert past the point where the body is ready to begin its maintenance window. You weren't designed for any of that. Every cycle described in this video evolved over hundreds of thousands of years under the assumption that when darkness came, you would stop, that the world would go quiet, that the process would run uninterrupted. So here's the question worth carrying with you tonight. When you close your eyes and assume that nothing is about to happen, what if the hours you have been treating as downtime are actually the most biologically active hours of your existence, and you have been scheduling meetings over them?